In this video we will create a VEX code which is going to automatically convert a single edge selection to the edge loop selection. So at the end of it we should have something like this, a group with the 3 selection edges, and it should give us a detail attribute that we can reference, and it's going to select the edge loops of this of any geometry, or even something like a bigger one, even with the, let's say, many points. We will basically instantly get our edge loop selection, something like this. So this is a great, I think, exercise for the VEX code, because we do a lot of converting values and creating functions and all of that. So even if this code is not the most useful one, I think it's great for knowing more about the VEX. So I actually recording this right after I finish this, so this is going to be end result, and let's get to it. And I actually bought a new mic, which is actually, this time it has a stand and it's right in front of me on the desk. It's not a headphone mic, so I think the quality is increasingly better. So, well, it's a lot better than my previous microphone, which is just from the headset. So I feel like I'm recording a radio show, something like a Art Bell Coast to Coast AM. Anyway, so let's get to it. Let's start with a very simple setup. So I'm going to put down a sphere, and let's make it a polygon. And let's do the polygon mesh so that we can, with double click, select some edge loops. Now let's put down a group node. Actually going to need 2 of these and also 1 wrangle. So let's connect them like this. So we connect group, then we connect wrangle, and then group again. In this wrangle node, make sure it's detailed, and let's actually select, let's give it a string parameter. Let's call it edge loop. Let's copy it also as a label. Apply, accept. So this is where we're going to, since in VEX we can't really write out any, basically set parameters with VEX. What only we think that how we can get information out of it is to write it into the detail attribute. So basically we're going to write it to the detail attribute, and then we're going to, in this string parameter, reference this detail attribute, and then we're going to reference it in our group underneath. So this is going to reference the, basically just this parameter, which we're going to paste inside here. And this group node is only for the convenience of the selecting some edges. So let's go ahead and make sure it's at edges, and let's select some, maybe 2 edges, something like this. So we know our syntax, and we can actually reference this inside our VEX wrangle as a base, as basically just as a group selection. So we can easily select new groups and test them all out. So you can see that there's basically just a P in front of it and a hyphen at the end of it. So this is a string. This is a single string. We have to basically just strip out all the hyphens and the P's to the integer, pairs of integers, and then work with the integer data as a pairs. So you can see it's just a selection. It's edge is just a selection of 2 points paired together. So 7, 4 and 7, 5 and 7, 2 and 9, 6. Let's say for our edge loop we need to, and for the, let's say we want to select more. So let's say we have 2. You can see it goes in order 7, 4, 7, 5 and 7, 6. So this is edge loop. And if we double click on it, you can see it goes from 75, which is here. Now let's go to the end of it, and it ends with 75. So this is edge loop selected. So all we have to do is create this kind of a string pattern for every selection that we make, and only data that we have is to work with. It is 1 and 2 edges like that. So I think this is good. Now let's start working with it. Let's start by getting our base group values inside VEX. So that's going to be a string. Let's call it edge selection. So this is going to be chs dot dash group 1, and the name of the parameter is base group, something like this. Actually, let's print out on a console. So what I have, actually I have macro on my keyboard, so I can always by one press get our printf, and I'm going to copy it, get inside here, and let's actually take a look at the console. You can see in printed out, so that's just to make sure that we actually have a reference to our edge selection. So let's delete this. Let's start by stripping these values from the p and the hyphens. So let's put in a for each loop. There's going to be a string, and let's call it edge pair, and the array is going to be edge selection. But before that, we could do basically by this one line we're actually going to also split it. So let's use a split function, and all of this has to be inside here, and we want to split it by these spaces, something like this, and it's going to actually return an array of the values. So we know that every time we select the group, it's going to be separated by a space. Inside here, we basically get the string array with separated by this. So that's why we can use a for each, which is for the arrays. So we can run by every pair of the edges that we have selected inside here. So inside here, we want to strip from the p. So that's going to be a, let's call it a string. Let's call it a stripped, which is going to be a strip function. The value is going to be a edge pair. So this one, let's copy it, and by the string of the p. So now we have get rid of the p value from our pairs. Now I want to actually split it. So let's create another array with the, so this is basically array within an array. So we have array of these values, and now we want to actually get the array of these pair values. So we want array of 7, 5 and 7, 6. So let's create another array. So it's going to be also a string array. Let's call it a string pair. It's going to make sure it's an array. And inside here, what I want to do is just use another split function. So in this split, we want to split the edge pair. I actually want to use the stripped because we have stripped this one. So this is a single string. I want to strip from the p, and I want to strip by the hyphen, like that. And now we have our strip array, and the last thing we have to do is actually convert it to the int array. So let's go ahead and do that. Let's create a int, let's call it the edge cell int, and that's going to be our final int. So that's going to be an empty array for now, and let's run through our string pair array. Let's call it the point, since it's a point, int. Let's call it a point, and array is going to be our string pair, like that. And all we have to do is make sure that we append to our currently empty array, which is edge selection integer. We have to use the a to i's, and this is the edge point, this one. So we basically a to I converts the string to the integer value, if we can do it. So we know that it's doable for it. So that's that. Close edge point. So let's take a look where the problem is. Actually, for each is going to be a string right there. Right, we have a string. That's my bad. And let's actually print out and take a look at it. So we should now have a 2, since we are running this 2 times, since we have a 2 selection, this should copy 2 times this array of selections. So let me actually turn on the console like that, and let's print out the edge selection, like that. You can see we have now array, that's an int array of every selection that we 75. This looks correct. Let's actually reselect some of these. Let's select maybe 4 of these, like that. You can see, and now every time we see, we have a perfect selection of all of the edges as arrays of points, like that. So this first part is working very nicely. So let's move on. Now that I'm reasonably happy with this conversion, let's actually talk about how can we get our edge selection. How can we actually traverse the edges to get our edge selection. So let's start with the simple selection that we would probably have when we want to get our edge selection. So this is edge 99, 100. And let's think about it. How can we select? So this goes into the concept of the half edges. So in Houdini help, there's actually very nice, easy to read up the kind of a concept behind the half edges. But inside this tutorial, we basically can imagine this one edge that we can select is divided into however many parts this edge is actually shared with the polygon. So we can imagine this edge is actually is basically made of the two half edges of both of these polygons. So polygon 121 and 97. So these have kind of a half edges create one edge that we can actually select. So this would be the same as let's say I put down a poly extrude. So you can see that this edge, it's still 99 and 100 now. No, points a little bit of a change. You can see that now this edge is actually created from 3 polygons, because this edge is actually shared with the 3 polygons. So you can see if I move it, you can see it's just the one edge selected. So this is kind of a concept behind the half edges. So what we want to do in this tutorial to traverse our edges is get our edge and actually get all the polygons that are associated with this half edge. And from this polygon, we want to get its actually point. So basically all of the points that belong to that polygon. So this would be a function poly primitive points, prim points, or whatever it's called. So you can imagine that from this polygon would be these 4 points, and for this there's going to be overlap with these 2 and these 2. And if there will be 3, then there will be even more points. But you can see that these are actually shared, but it doesn't really matter. So think about it as if for this example we have these 6 points, and for us to select the next one, we know that these cannot be the next point. But if we take a look at these points that this edge is actually made of, which is 99 and 100, and we get the neighbors of these points, basically neighbors that are connected directly to this point, which would be 96, 101, 124, and 99. You can see there's actually going to be an overlap of these points, of the primitive points, and the points that are actually from the edge selection. And the only point that's not going to be in both of these lists is going to be 101, which is our next point for our edge selection. And then we have to repeat it to the next one, like that. And let's say we end up with the edge. So not always the edge selection is going to go around the whole geometry. So let's say we have basically somewhere the hole in the geometry, and we want to select to the edge. This will be also very simple, because once we do not find any outlying points, that's not in both directions. So this will be like basically again this edge selection, these points 6, and then these 6, and basically all of these points are also going to be in our half edge primitive points. And then we're just going to stop the while loop. So that's going to end our edge selection at this particular moment, and that's it. So that's kind of a theory behind it, and let's get working on it. First of all, let's create a couple of functions that we're going to use a lot in our loop. So what we'll do is now get our function for easily getting all the edge points that are associated with it. So this means we have to get our edge loop our edge selection, we have to get the primitives that belong to this all the edge selection, all the half edge selection of this edge, and then we have to get the primitive numbers of it and get the points of it. So basically all these 6 points. So let's get to it. So I should create initially, basically it's going to be a function call, but for us to easy to see, so that I can actually print out everything that that it actually does, I'm going to wrap it around the function at the very end. So let's start with the idea that we have an int array of 2 values, something like these two. So first of all, let's separate this int array into 2 different integers. I'm going to call it pt1. It's going to be our array selection. So let's actually do this. Actually, I guess we could actually going to create a, let's not touch this one. I'm just actually going to just create a random int array that's going to be something like this, and we're going to actually reference the actual points of it. That's going to be 99 and 100, something like this maybe. And now let's start by separating these values. So a couple of functions that we're going to use. It's probably easier for us to separate into different variables. So I'm just going to call the pt1 is my array with index 0 and copy it, and 1. It's going to be pt2, something like this. It's going to be a lot easier. So now we have to use a couple of half edge specific functions. First of all, we need to use a point edge function that's going to actually turn the resolve the internal number of the half edge of these points. So there's could be a couple of things. So basically, in this function, in a couple of other functions, actually the order that we reference these points actually matters, but for this function, it actually doesn't. So let's call it an int. I'm going to call it initial half edge, something like this, and use the point edge function. Point edge geometry, and it needs the 2 points. So that's going to be pt1 and pt2. Let's actually print it out, and let me take a look at it. So what is going to print out is going to be 460. So this is going to be basically the next basically internal half edge number, which is 460. So that's very good. And now what we have to do is loop through these. So first of all, we have to make sure that this half edge actually exists. So we could let's say we could also give it a non-existent half edge. So let's say we want to half edge from point 99 to 125. So 99 and 125. You can see it's going to turn a -1 because this half edge doesn't actually exist. So it's not actually physical because these points are not connected. So we're just going to run the next part of this logic only when the half edge is not actually a -1. So let's start with the if the half edge, so initial half edge, let's call it is bigger than, actually it's just not a -1. So this is what we're going to do. So what we're going to do is check out how many equivalents to this half edge that we just got there are. So there should be 2 equivalent half edges because there's 2 polygons. So let's try it out. And we have to give it the number of the half edge which we just got with the initial edge, like that. And let's actually print it out. How many equivalent count we got. You can see we have gotten 2 of these, and we can actually check it out because let's go to the group and let's actually extrude this point. So if we know anything about half edges, this should say now actually, this should actually print out 3. You can see it actually does. Now there's 3 equivalent to this half edge, basically this main edge that we held select, that we can see and there are equivalent 3 half edges, basically 3 polygons that are also shared by this edge, half edges. You can think about it as a 3 half edges are this one edge is made of 3 half edges of these polygons. So this works, and let's actually delete this. So we know this works, so that's very good. And now that we know our half edge equivalent count, we can think about as how many times we want to run through. So it's basically going to follow how many polygons that we need, that there are to this edge selection. So what we do is to run through the basically 2 times. However, we have equivalent count of the half edge. So let's put it for each, and let's call it a half edge equal count, like that. So this is going to run now 2 times. First of all, let's get our half edge primitive. There's also a function for that. Let's call it a half edge prim. If edge half edge, it's called equiv half edge actually prim, like that. And then we have to give it a half edge. So our half edge right now is our initial half edge, like that, something like this. So let's actually print out the polygon numbers also. So this should be let's clear out and again 121 and 121. So this is good because it runs 2 times and we do not change the half edge, basically the initial edge value. So in this loop we actually want to change it to the next one. And now let's get the primitive point. So first of all, we want to create an empty array out of these loops. So let's do this inside here before any of these if statements. Let's call it edge points. Edge prim PTS, something like this, just an empty array so we can append its values to. Now this we have our prim int, so what we do is get in here actually the prim point. Let's call it PTS, something like this. There's a function prim point, geometry is going to be 0, and prim num is going to be our prim that we just got from the h prim, like this. So we have our points, basically 121 all the points, like that. And now what we do is actually basically I do not want to duplicate values inside the array. So what we can do is actually run through them and only add the values that are not inside it. So let's run through this loop. So for each, let's call it prim pt, and the array is going to be prim pts. So also it's going to be int value for the prim. So and then so what we do is if, actually let's do it in another variable. So what we do is actually go ahead and find this value that we run through in our h prim array. So it's going to be let's call it a val found, something like this, and the function is called find in an array of h prim pts. We want to find the prim pts, like that. And so this value is actually going to return the index of the position if it finds it. So if it doesn't find it, it's actually going to return a negative value. So what I'm going to do is actually if the val found is smaller than 0, so basically it's going to if it's a negative value, basically this means that it hasn't found it. So then I want to append to the edge prim pts our edge prim pts prim pt, like that. So now we basically, if it doesn't find it, append it to it like that. And then one last thing I want to do is actually increase this initial edge value. So once we make sure that it's actually, so we run this, so for each the prim of the PTS. So basically after this one, after this for each, we want to increase the initial hedge. Basically we want to override the initial hedge. And it's hedge, it's called, the function is the hedge next equiv geometry is 0, and the edge is going to be the current that we are running over. So it's going to be initial edge, like that. So you can see by basically taking the same edge and it's feed into the actual initial edge, like that. And let's actually print out and take a look at it. So after all of this, let's actually print out our edge prim PTS. So you can see we have an array of points. So let's take a look at this. So we have array of, so this is our selection. There should be these points in it. It's 99, 100, 124, 123, 75 and 76. You can see this works very nicely. And now let's actually create a function out of this bunch of code, because we're going to run this many times. So let's delete this my array, and also this pt1 and pt2 is actually going to be a part of the function call. So when we're gonna call a function, we're actually going to give these variables at that moment. So let's delete this. Let's take all of these. Let's tab it out. Let's call it a function. Int is going to be an int array, and let's call it get all edge PTS. Let's get all edge points, something like this. So let's call it int. So let's get an input. That's kind of a default. So these inputs would be all of the zeros that we have inside here, basically referencing the geometry of the Wrangle node. And let's call it int pt1 and int pt2. And now what we have to do is take all this code and put it inside the brackets, the rounded brackets or whatever they're called, and we also want to return some values. So what we'll do is actually return the edge prim points. And since, let's point enter, so after all of this, if all of that, we want to return edge prim points, like that. And let's actually test it out. So let's actually delete these. We don't need these anymore. And let's actually test it out. So let's so int test array equals get all edge PTS. So input's going to be 0, 0.99 and 100. So that seemed to be work. Let's print it out. Let's take a look at it. And you can see it's basically the same thing. And actually, let's go here to this group and actually let's extrude something maybe like this. Let's take a look at how our points actually changes. So I'm going to clear this. Oh, you can see now we have more points. So this should also include the 267. 267 and 266, like that. Yes, it has included also these. So we know, so this function now works very nicely. We can delete this one. So that's this part of the get all edge PTS. So this is done. So now we have two bits of code, our initial transfer and this one. So let's move on. And now let's work on getting all of the points. So I'm actually going to pick some something where we do not loop around whole geometry. So I'm going to go and select something like this. So if we select edge loop, it would actually stop at some point, something like this. So this should be good. Now let's start working on the getting the next point function. Actually going to right away make it. So let's go ahead, and it's going to be a function. It's going to return the integer value of the single point that's next. And let's call it get next pt, something like this. So let's make it a input int. So it's going to be a, let's use the same naming. It's be pt1 int pt2, and also I want to choose which one is the current point of these. Basically these two will be made of the edge 97 and 73, and let's say we want to get the next point of either of these points. So let's say of the pt1. We're gonna call it a current pt, something like this. So first of all, we want to get all of the neighbors of the current point. So let's create an array, current pt neighbors, and that's going to be pretty easy. Just a neighbors function, and it's going to be our current pt. Now what we're going to do is get all of the HPTs of the, basically use the same get all the HPTs of the edge, where we're going to put the pt1 and pt2. That's going to be another array. Let's call it all HPTs, something like this, and get all HPTs. So our function was input and point. So it's going to be 0. Well, actually input. I should also write inside here input, and then the pt1 and pt2, something like this. So now we have our two arrays, and now what we're going to do is get the neighbors of our current pt. So let's assume from this edge it's going to be 97. We want to see which point is not going to be in our all HPTs array. So let's create a empty array where we're going to loop and append the values that are not inside the all HPTs. So let's call it all unique PTs, something like this. And now what I'm going to do is actually loop through all of the current point neighbors and find the values that are not also inside all the edge points. So let's put in a for each loop. Let's call it int current pt neighbor. Let's run through all the current pt neighbors like that, and let's use a if statement. Let's use a find, and so basically we want to find in all the HPT array, find the current pt we are running over, like that. And if this value is, basically if we do not find it, which is smaller than 0, if it's negative value, we want to append our current pt we are running over to all the unique PTs, like that. And let's turn it into let's turn it into the function for the let's return array. So basically curly brackets after the int, and let's actually return it. So let's try it out. Let's return all the unique PTs. And let's call it. So let's call it a test array. Let's call this function get next pt. So let's get something like 2 and 26. So 226, and let's get next point of the 2, like that. And let's print it out. And let's take a look at it. It should return a 0. So we know that next point for the 2 should be 0, which is correct. And let's actually get for the 26. And for the 26, next point is going to be 50, which is also correct. And the next thing I want to show is how can we actually end our selection, because right now when we're going to keep running this code, we are going to return some sort of the values. And the example it would be something like this, where our array that it returns actually 0 to this huge array is actually returned. So that is because of the, let's take a look at, so we have a 0 and 2, and we say that our current point is 0, and it says, well, return the next point of the 0. Well, right now we are returning array, but for our end function it's going to be actually just the integer value. You can see there's a bunch of points that are not actually inside the edge selection points. So our edge selection points would be only these 4 points, like this. And all of the neighbors of the 0 that we are referencing inside here actually are not inside the edge selection point. So between 24 and 4, you can see it returns all of these points. So we want to stop this selection. And the best way to do it is just return a negative 1 value. It's kind of like Houdini. It returns a negative 1 when basically the value doesn't exist. So let's do this like that. So I'm just going to do the basic one. I just want to make sure that I get the array of 1 point, and if I get the array of 1 point, I'm going to return this point value, and that's it. And if I do not get the array that is length of the 1, I'm just going to return a negative 1. So that's how I'm going to handle it. So first of all, let's make sure that our function now is going to return integer, and now we're going to ask if the length of the array all unique points equals 1, we're going to return all unique points 0, basically the only value that it has 0. And if it's not, we're going to just return a negative 1, and that's it. And I actually moved a little bit of a window up so you can see more of it, so my bad if I obscured a little bit of a code. So now we have these two functions. Let's actually start by looping some values to it. So let's go to the very first bit of code we created, where we separated from where we converted this string to the array of 2 points, and let's do it inside the for each loop, since this is going to run as many times as we have a base group. So for now, let's make sure we have only one, so we can see what's going to happen. So first of all, I want to do a couple of things. First of all, let's run it. Let's do a for each loop, and let's run for each edge selection integer. So basically, through the array of pairs of points of the edge selection. So in this time, I'm actually going to use the item type, which is going to be integer. I'm going to call it index. So this is going to just return the index value of the array position of the value of the point inside the array. So there's not going to be much of points because there's only going to be 2. So the index is going to be either 0 or 1. Point, let's call it HPT, and the array is going to be select edge selection int. So this is going to be our for each loop, and this is also going to be int. So right now we want to make sure that for every, so we are going to loop this only 2 times. We want to make sure that our current point is going to be different for both of the times we run it. So this we're going to use the if else inside the if else in a one line. So pt1 equals, so pt1 we have to now check the condition which is going to be true or false. So that's why we wrote the index in the index equals 0 question mark. So if the index is 0, we want to select the edge selection int, and let's say this is going to be first index, and if this is not, put in a colon, then it's going to be edge selection and the index is going to be 1. and then just duplicate it and change the values to 0 and 1 and PT2, like that. So this ensures that every time we're going to run this 2 times, and every time the PT1 and PT2 is going to be actually different. We can actually print out the, let's print out the PT1. It doesn't like something, so let's take a look at it. Oh, I forgot. Int, like that. You can see now we're running 2 times, and the PT1 every time is 97 and 73, and this should be flipped for the PT2 right now. So yeah, this is exactly what we want. We're going to start with the current point being flipped, because we're going to grow our edge selection on both directions, and it has to be, a current point has to be different for every loop that we go. So that's good. And now what I want to do is actually create an array that I'm going to append the values to. So I want to do is outside this for each loop. So I'm going to call it int, let's call it edge loop values, something like this. And I want to start with the values of the edge selection int, the one we are looping over. So we can't really append to the already existing edge selection integer we are looping over. So since this loop is still going to run 2 times, since there's when it starts to loop it has 2 values, but for the second loop it's going to actually sample from our new array, which is going to be modified if we append to it inside the loop. So we're just going to copy these initial values to the new array and append to this array inside from the loop. So let's do it like that. So first of all, this is the part where we should do a while. But before we do while, let's actually demonstrate how it will look. For since I do not want to crash, I'm going to use a for loop. And in each for loop, I want to run it maybe 20 times, something like this, just to show how it's going to work. So in this, I want to get our next point. So our next point is going to be get next PT. So it's going to 0, then it's going to PT1, PT2, and let's say our current point is going to PT1. So this is going to return the next point. Right now, since it's not going to change, it's going to return the same value. And to do in this loop, we want to update these PT1 and PT2 values for the next loop. And now let's update these values PT1 and PT2. First of all, let's go to the guides and actually let's make a guide font large, so these points are a little bit larger, like that. So let's take as an example this edge selection, and let's say our current point PT1, which is our current point for our next PT function, is going to be now is going to find 50. For the next loop, we want to make sure that the current point, which is PT1, is actually our current next PT 50. So let's make sure that it's so basically PT1 equals next PT. So it's basically going to override this initial value inside here. So now for next loop, PT1 is going to be 50. You want to make sure that we basically 72 is being kind of thrown out, and PT2 is going to be PT1. But for that we want to assign it first before we assign PT1. So PT2 equals PT1, like that. And since this loop is going to run 20 times, let's actually append these values to our edge loop values. But before that, we actually want to make sure that we actually append them correctly. So first of all, let's go to our group, take a look at our, let's reselect maybe something like this. You can see everything is in here has to be in order. So 96 followed by 97 and 74. So, and if our edge loop is going on both direction, we do not want to, let's say 96 appended to the end of the array at the end of the age selection, which will be 74. So basically we don't want to 95 to be inside here, basically at the opposite sides of the 96 when we append it to the array. So you want to either append it or insert these values. So let's reselect our edge loop like that. Let's go ahead and do it like this. So let's put in an if. So if the pt, if the index equals 0, so basically before the if we are running it the first time, we know that at the first time our pt1 is actually the 0. Basically it says it's the first value. So the next pt is we want to actually not append. Append would actually append at the end of the list, which is our edge selection int value. So basically it would append from 95 at the end of the list, which is 72. We actually want to use insert. So use the insert. So the array you want to edge loop false. So the index you want to at the 0, it would be basically index of the insert would be 0, which is means at the front of the array, and the value we want to append the next pt like that. And else, basically since it's just so you run it only 2 times, basically the index is going to be either 0 or 1. Else you want to, and now the second time we actually can append to the edge loop files the next pt like that. So they should be actually correctly. Now let's actually print out the values. So once we have run all these loops, let's print out the edge loop files. So you can see we have a bunch of negative ones, which is good, which means we are not getting any next points. But let's take a look at our group is 96 and 72. Let's find these values, 96 and 72. So like that. And so for the 72, the next one should be 48, 24 and 0, which is correct. And on the opposite side, it should be 120, 144, and it should end up with also with the 1. You can see there's a 1. So we have correctly appended these values. So this works for now, but we really need to get rid of these negative values, and also we need to make sure that it doesn't add any duplicate values, because let's say our edge loop is going to be something like this. It's going to actually loop over the values. Basically, let's say I loop over not 20 times but 200 times. You'll see that it's basically going to infinitely loop over the values, because there's always a next value for this edge loop. So we need to take care of that. So let's start by, so it's going to be with the while loop, but I'm not going to use it just now. I want to make sure that this while loop is actually going to stop at some point, and then only need to use it. So first of all, let's get rid of all of these negative values. First of all, we want to run this if else only if our next point is not -1, and if this point is not already inside our edge loop. So let's do it like that. So first of all, let's create an int value. Let's call it check existence, and it's going to be find. So in this find, we want to find in our edge loop value, which we are adding our values, inserting and adding. We want to find our next pt. So if this value is not found, only then we want to append or insert these values. So let's go ahead and let's do it like this. So this belongs to this one. So I went to all of these. We want to tab in and write in another if statement. Let's clear these out. And if check existence is smaller than 0, and only then we want to run it and close down the if like that. So you can see we have already got rid of many of these points, but you can see there's also still one negative one, because at one time it's still going to add -1. So all you have to do is just add another end statement, and the next point is not equals -1, like that. Wrong order. Is not equals -1, so we have get rid of, so it would add one time -1 because one time it can add one value, but second time it won't, like that. So now we have got rid of out of all of these points. Let's actually convert this to the while loop now. Let's do this while pt1 is not -1, is not -1, and it's going to be while, like that. So at first nothing is going to change because this pt1 is at some point going to be -1. So now what we're going to do is actually make sure, let's go to the group and let's actually select the complete for loop, something like this. And you can see it's already starts to go infinitely because at no point I just quickly pressed escape so it doesn't crash actually Houdini. So what I actually want to do is make sure that this while loop actually at some point actually breaks. So let me quickly put in a while on as a commented out so it doesn't crash Houdini, because most likely it's going to crash it. So all I really want to do is, so basically this if is going to run only if this doesn't exist, but we know that if we have a whole edge loop selection, already at the very first loop it's going to go around and it's going to find its own value at some point. So what I'm going to do is just going to write in a if, actually else statement, and in this else statement I'm going to, else is going to be if it actually does find its value. So if this if there actually is already a value, I'm going to, it's actually going to just break break, thank you. And I'm just going to comment it out right now. You will see we actually do not get an infinite value anymore because we are now breaking the which would be an infinite loop, which is right now, but we are now breaking it. One last thing we want to do is actually, when we select the edge loop selection, we want to also end the edge loop selection with the same value. So let's take a look at it. So let's say I have this value. You can see it's an edge loop selection that goes around the entire geometry. It starts with 98, it also ends with 98, so we have to implement in our loop. So right now it's actually our while loop do not allow any of the duplicate values. So inside here it inserts another value and it stops at 101. So basically when next value is 101, it looks at the next value, it's going to be 100. So in next loop, the next PT is 100, but it doesn't allow us because 100 is already at the very beginning. So we just have to add another value. So you can select one value and we're going to go to this else statement. So first of all, comment out this file because it's actually, I crashed Houdini because I wrote the code and it suddenly, the while loop didn't stop, so be careful. I want to write it in one line. If, first of all, I want to add only one. So if the index equals 0, so index is just, since we ran it one time, we just want to add the first time. The index is 0. I want to insert into our edge loop values index, so we need to add it into front of it, so that's at the front of it, and value we want to next pt, like that. Let's comment out again our while. You can see now our loop is actually at the very end of it, it's also inserting 100 and we have also 100 inside here, so this is good. And another thing, we have to make sure if we do not add any negative values. So this time our edge loop is not continuous, it just ends with at the 0. What we want to do is actually also make sure that the next point is not -1, because even though in here we do not allow -1 inside here, as long as its index is not 0, it's actually going to, as long as it's 0, it's actually going to add -1. So basically you have to do the same thing. Actually going to copy this, and next PT is not -1 like that. So we have now created the arrays that we now just have to create a string out of it. And now for every loop that we have run, we want to convert this edge loop file integer array into the string array, because we're going to want to use the join function and create a single string out of all of this. Would be kind of a that it would replicate this kind of a base group. So let's go ahead and do that. So let the for each loop do its job, and let's create a string array which is edge loop vals str. So this is going to be our CS. For now it's going to be empty. We want to run through all the edge loop files. For each, let's call it doesn't really matter, so pt in pt, and array is going to be edge loop vals like that. And what I want to do is append to the edge loop strings. So we want to e2a, which is going to convert the number pt to the string value like that. So now we have a string value of all of these. And what we want to do is actually join them together and add a p at the front of it. And now let's create a string. This is going to be a single string. Let's call it edge loop str. And we're going to use the printf. The formatting is pretty, so we know that we want to basically put in a p, and then we want to join all of the values. So what I'm going to do is, the syntax is basically percentage mark and then the s, which is basically indicating what kind of value you want to add to it. Since it's a string, you can read up kind of a, for me it's basically any of these. There's many letters that you can add, but for me I think my default one is the D one, and it still usually works, but it in documentation it says if you want to print out the s, if you need a string, it's going to be an s. So that's good enough, I guess. And all we really now have to do is join, use a join. So join is actually basically it gives out a single string. Basically we have to give it a string array. It's going to convert it to a single string with a spacer, and the spacer, we know it's we need a dash like that. Close it down and let's take a look at it. It should we have the one to printf like that. So we have now a string of all of the values. So let's take a look at it. Let's copy, paste it. You can see we have a p 1, 2, 3. This is correct. We have another p because we have basically two values. And now that we have our each loop string, remember that this is only going to return basically for each loop only single string. We want to capture all of these strings outside this for each loop. So what I'm going to do is actually create a string array. Let's call it all edge loop strs strings, and that's going to be a string array. And what we want to do is inside make sure that you are inside for each loop. We want to just append them. So I'm going to delete this printf. I'm going to append to the all edge loop strings a value of the edge loop string like that. So now we can actually print out this all edge loop strings outside here, and then now we should get a single array with all of the values, but it's still an array. So what we want to do is actually now convert it to the single, combine it in a single string. So what we can actually do is use a join. So this is going to be our complete string. Let's call it the complete edge loop string. It's going to be using a join, and in join we have to give it an array, which is going to be our all edge loop strings, and the spacer is going to be just a single space like that. So now what you can do is set a detail attribute. Geohandle is going to be 0, the name is going to be edge loop selection, and the value is going to be our string, like that. And the mode we can actually delete, like that. And now if you take a look at our detail attribute, you will see we have written out this inside the detail attribute. And now what we can do is actually reference this detail attribute inside a group node. And now to see in action our string, let's actually go ahead and get another group node connected to the same geometry, and let's actually go ahead and reference our detail attribute. So the easiest way is probably to the reference and see in data. And what we can do is select this attribute wrangle. It's automatically going to select it, go to the attribute, global, and that is our attribute, like that. So you don't have to write it in. So, and that's it. And let's take a look at it. You can see we are now getting our edge loop selection. And if I go to my group and select other edges, like that, well, something like this, go back, you can see we are still getting our edge loop selection, like that. And now let's select, I put in a different geometry. I just want to select different edges, something like this. And now to check it out, you can see it's basically instantaneously going to give us the edge loop, so that's nice. The cook times are not big at all. I actually did some performance monitoring, and it was really good. So I was wondering maybe it's going to cook for a while, but I guess you need a lot more points to slow it down any noticeably. So I'm pretty happy with the speed of it. So one last thing I wanted to add is to make sure that this for each loop where we get our string is going to run only when the length of the edge loop vals is actually 2, because right now we can actually select 3 points like that, and if you take a look at the group, you can see it still runs, but it's only in one direction. So basically the selection is not going to be correct. So just one thing that I should probably add is make sure that this for each loop it's going to run only when the length of it is 2. So let's go ahead and do that. So basically just inside here, if length of the edge loop vals equals 2, and then we want to, let's delete these, and want to tab in everything in a for each loop. So for each starts in here and ends in here. So let's take all of this, tab it in like that, and make sure you end also with the squarely brackets like that. So now we are running this only when it's 2. So let's take a look at how it's actually. You can see the base group actually now is not. It's basically the same one. So that's good. It basically won't make. But if we select something like this, our edge loop is now selecting. So obviously we can start looking at many exceptions when we want to add to the to this logic of this code. So, but I think that's it for this video, because it's already well over 1 hour long. So see you next time.